1 o'clock. Welcome, everybody. Welcome to another HDF clinic. I checked our worksheet and there was one question from Robert. And Robert, are you here?
Yes, I am.
Oh, welcome. Would you mind? So I pulled up I believe the article that you are referring to.
Yes.
But let me just make sure. I think John Beatty had two posts in there. Okay, one was a reference, but is it this one? Convert seismic data, and then he posted here. Are you interested in why data stores via HSDS support? Is this the text that you are referring to?
Yes, that's the one. You see his link where he says a little bit in the second paragraph, you can read about the design here, and then he references an article on this single object interface from HSDS.
Okay.
And my question was, that sounds completely new to me in terms of the way I thought of people using HSDS. So I thought maybe a little explanation there, context and how people might use that, and how to compare that a little, the usage in that manner with, let's say, conventional S3 VFD type of an interface. And then I had one follow-up, but I'll let you take it from here.
Okay, thank you. Yeah, great question. So I think what he's referring to, just looking at this, is that, okay, there is in a way call it an HSDS native storage way of storing HDF5 objects, meaning groups, data sets, and whatnot. And then there are other, call them compatibility, some people would use the term legacy, ways of storing HDF5 data. And I'll briefly refresh everybody on what they are. So the native, so to speak, way of storing data in HSDS. So HSDS is the highly scalable data service, and there are basically two parts to it. There is a front end and a back end. The front end basically deals with responding and sort of channeling or marshalling calls, requests from clients, and then and there's also a load balancer and so forth. And then on the back end, there is a storage back end that basically has multiple service nodes and data nodes, and where the data nodes are in charge of certain, call them partitions, regions in your S3 space, so to speak, that they are servicing, that they are in charge of. And individual HDF5 objects, let's say a data set, is similar to chunk layout, is basically stored as a JSON object. So that this is just one S3 object that looks like a JSON file if you were to store it in a file system. And then the values of the data set itself are like chunks in a chunk data set. They are sort of sharded or tiled, call it that. And then each of these shards or tiles or chunks is actually stored as an S3 object in and of itself. So that's the, if you wish, the native way of storing HDF data in HSDS. And some people would say, well, isn't that just like ZAR? There's this ZAR format. And yes, the answer is similar ideas. I mean, there are only so many good ideas, and this is one good idea. Many people have adopted that style of representing things in S3. And then John, and that's where we are coming to this topic here. Some people had a requirement where they said, well, if you take my HDF5 files, and then you would sort of shard them or transform them into this other layout, I'm concerned about losing data, data getting corrupted in the transformation process. So it just introduces additional unknowns. And they would say, well, can't we just take my HDF5 files and put them into S3 as blobs. So in S3, you have basically buckets and blobs, and buckets look like directories, if you wish, and blobs are just objects in S3 speak. And you can treat a contiguous byte stream, that's at least what a file is logically in a file system. You can just take that and store it as an object in S3. No changes to it, byte for byte, identical to an HDF5 file in the file system. But then, of course, the problem with that is in the past, HSDS did not support that layout. But at some point, since there was, I think, sufficient demand, John said, well, assuming that I have such a blob, it would be tedious to, for example, then every time somebody accesses something or wants to just retrieve some metadata about this blob, I have to go to S3, pretty much load it onto some kind of data node or service node, an EC2 instance. It could be also just a node in a Kubernetes cluster. I have to load that file, or at least I have to know which regions of that file, of that byte stream I have to load, and then I can process this and so forth. And that is, of course, from a performance perspective, pretty slow. So what John ended up doing is to basically say, as part of the, call it the staging or the loading process, when you take such an individual HDF5 file, you basically look at the metadata, and you basically create a little, call it a manifest or some kind of metadata memorandum that basically keeps track of the objects in that file, the path names. It also, for an individual data set, would keep track of, depending on what the layout of that data set in the file is. So let's say if it's contiguous, you only have to keep track of basically where do the bytes that correspond to the values of that data set begin, and then basically arrange a size of how many bytes to read to fetch the whole thing, what its dimensionality is, what its data type is. And likewise, for a chunk data set, you would try to keep track of, you can retrieve for an individual chunk where, at which byte offset in that file is that chunk located, and how big is it actually? Because if it's compressed, let's say, then typically the size of the chunks, the physical size of the chunks varies from chunk to chunk. And so you basically have then this blob, this S3 object, and you have a secondary, call it an S3 metadata object, that basically contains that offset, size, range, type, what have you information. And that is sort of the, call it compatibility layout or the legacy layout, call it whatever you want. And I think that is what John means here. So you can use that with HSDS if you are concerned about, I really want to make sure that HSDS works with byte identical copies of my HDF5 files, then that's an option.
Okay, and John's okay. That's interesting there. And then I think it might have been on the single object write-up. Currently, it's read only. If you use this approach, that's not a permanent limitation. That's just an implementation limitation at this time.
Yes, that is an implementation limitation at this time, because, as you know, S3 objects are immutable. So once you have created an S3 object, you cannot do random access style modifications. So there is, for example, for a blob, let's say it's a large blob in the case of an HDF5 file, and you can do what's called range gets, meaning you can do a get, but you don't have to necessarily retrieve the entire blob. You can say, well, starting from offset X, read me this many bytes, and this is a range, so read me that byte range. However, there is no, call it a range put. So if you wanted to access and modify an S3 object as like a byte, a region in a byte stream. That's S3 doesn't support that. So what you would have to do is either retrieve the whole object and then basically rewrite it and then create a new object or overwrite the existing object, or in practice, depending on how write heavy or how update intensive that use case is, you also might want to just maintain a list of modifications on the side of diffs, so to speak, where you store the original state or some kind of initial state, and then as you make modifications to it, you just sort of keep the regions and references to the regions in that original blob that were modified. Now, depending on how wholesale or how extensive these modifications are, that can get fragmented pretty quickly, and sort of, if you then want to read the whole thing, you would have to dynamically piece it together. So there are trade-offs left and right. So, and perhaps most of the use cases that John has encountered, or that sort of served as the driver originally for this approach, were perhaps read-only use cases. But it's really just an implementation limitation, and to make this performant would require quite a bit of engineering.
Okay. Okay. Excellent. Thank you very much.
Okay.
Yes.
Great. Well, thanks for the question. Okay. Let's see. Okay, I prepared a few notes here. Yeah, let's just go through our usual highlights. And by the way, I apologize for I noticed that the audio quality was pretty choppy last weekend, and I think it had to do with whenever I moved my mouse or something like that, or moved my mouse pointer around, it somehow, and I'm not sure if it's related to the CPU load or what, so I will try to not touch my mouse too much today to avoid this. Okay, just a reminder, we have this exciting constructing a simple terminal wall connector this Friday, 2 hours. It's a hefty tutorial by comparison, but I think it's worth it. But then on the other hand, I'm sure we'll have a recording available if you want to sort of enjoy it on your own time. And you can still register by all means. Another interesting blog post we just published, and if we get to it, tips and tricks today, we'll talk a little bit about the magic of HDF5 UDF. And then we had a little bit, a few things on the forum going on, but I'm just going to pause and ask, are there any other questions in the meantime?
No, Gerd.
Okay, good, thanks. So there was, this was actually a good one. So I'm as guilty as anybody of sometimes you read a post on the forum and you sort of, you just quickly scan it and say, yeah, I think I know, I've seen this question before, or somebody asked something, and then you're completely off track and you are getting off into the woods. And then unfortunately, sometimes for the innocent user, you bombard them with these deeply sometimes technical questions, and they were just asking something completely different. So not that bad, but something similar happened here. A user was asking about that he was unable to open a data set in an HDF5 file with H5 Pi. And again, it helps to really read what people are actually asking. He actually included also a nice little screenshot of the backtrace that he included. And then I'm glad my colleague Alexander spotted that and actually clarified and actually answered the question that this person was asking. He was basically, he wanted to, you have a data set that you are accessing with H5 Pi, and then you want to retrieve the value of that data set, or all the elements of that data set, let's say, or a slice. And the user thought, well, in Python, there is this converting something to an array method, and the person asking the question thought that that was the right thing to do in this case, which it is not, and he included the error message that he got. The correct way is really to use this ... notation, and then yeah, that will return a NumPy array whose elements are the elements of the data set. So yeah, it was just, yeah, I remember I asked him then something about compression and so forth, because I had completely missed that simple question that he had actually shown this example here. So yeah, yeah, my bad. Then there was another interesting twist. Remember last time we talked about that user who had these groups, and they seem to have a fairly large amount, or a fairly large number of subgroups, and he was sort of having recognized that traditional sort of iteration methods are pretty expensive. He thought, well, if I can parallelize that, then maybe I come out ahead. And so he was using H5L get name by index, and then he did this for loop on different MPI ranks. Or as we briefly discussed, yeah, you can also use H5L iterate with a callback. But it turns out that they are using BGFS. That's one of the popular clustered file systems. So many people are familiar with Lustre and OrangeFS and GPFS and so forth. But there are others like BGFS that seems to be popular in circles. And his file sizes were sort of around 1 to 2 gigabytes. And then the question is, again, his original question hadn't changed. How, if I really don't know, since a physical device or something might create the names of the subgroups in this, let's say, experiment file, you really have to traverse them and find out. You cannot know a priori what those names are. What do you do? Well, in this case, after I saw that, okay, it's a parallel file system, so yeah, iterating in situ, going back to the parallel file system, that's going to be a killer. But sort of as the saving grace here, since these files are only 1 to 2 gigabytes large, you can load them easily, or partially in particular, into memory using the core VFD. And all you have to do is set this file access property with H5P set FAPL core, and then iterate over these groups in memory where, yeah, you are really running at memory speed, so you're not going back to the parallel file system. And if those reads or those memory operations, they involve small byte ranges and so forth, that's as good as it gets in memory. So, and then I think the user replied and he said, yeah, that's an interesting idea. He wanted to try it. So I haven't heard back, but I would assume that it worked. And then, of course, you also get the benefit. Then you can read, if you want to process in bulk large collections of these files, then rather than spending multiple MPI ranks sort of trying to dig into the same file, you can have them just read different files independently and then do this operation on those files. And so that was good to hear. Then there was another sad story, and it happens. It happens, and we talked about this about a year ago. I checked, is that, yeah, somebody had an HDF5 file and somehow got it corrupted, and they were just showing, they were trying to look at it with H5 dump, and H5 dump was just printing out error messages complaining about that it can't find the root group and so forth. And the user was asking, well, is there anything to do, anything that can be done to salvage maybe some data and so forth? And the answer is perhaps. And then it really is down to the skill set of that person. And okay, how many people out there are fluent in the file format specification and so forth, and then also fluent in hexadecimal addresses and so forth, that brings that sort of circle of individuals to a very small group of individuals pretty quickly. And there is definitely a need for a tool, and this is something we have to think about. But then again, so the reminder, and I linked it here when we talked about this a year ago, we had this picture here where we talked about that the state of an HDF5 file that's open, there are really two components to it. There is something that sits in RAM, and then something else that has been flushed or written, or that was there to begin with on disk. And while an application is running and while that file is open, it's really the combination of the two that makes up, call it, the consistent state of that HDF5 file. And yes, unfortunately, what happens is if there is an application error or something like that, and that RAM portion just disappears, and sometimes perhaps data that is in transit that's just on the way from RAM to disk and just gets cut off and lost, then it's very likely that this HDF5 file will end up in an inconsistent state. And so coming back to the question, I should have jumped away here. There is actually something in the file format specification, if you are then brave enough to sort of dig into it. The founding fathers, or the creators of the HDF5 file format, they left sort of intentionally clues in the file format, so that if you were in a situation where you're dealing with a file that appears corrupt, that you cannot access with the regular library and tools, that you can then use standard just byte tools, Unix tools, to look at that file. And these markers or these labels, they really act as sort of orientation points, where you can, with a simple Unix command like strings, you can find them. So I just listed an example here. If you look in the file format specification, where it talks about the symbol node table, there is at the beginning, sort of as a preamble, if you wish, to symbol node table entry in the file format. It starts with these 4 characters, SNOD. And so in strings, with the Unix command strings, for example, you could search for all the symbol node tables. Just search for SNOD, and there could be some false positives there, but so just data that just happens to be SNOD. But that's rather unlikely. And then again, the file specification tells you exactly what to expect, and then you can actually pretty quickly make out whether this is a real symbol node table, or whether this is just random. And so markers like that, they clearly indicate that, as they say here, this gives file consistency checking utilities a better chance of reconstructing a damaged file. The problem is that these file consistent checking utilities actually never materialize, not to my knowledge. And it would be a great thing as a community effort or otherwise to create these files, because I think it's pretty clear what needs to be done and so forth. But yeah, it all comes down to who pays for that developer that will dig into this and write that tool. And then also, if we look for some usability here and don't want to make it sort of too geeky or sort of too low level, but maybe perhaps put a simple graphical user interface around it, then of course the costs go up pretty quickly. And I think that's, and on the other hand is, can you avoid corruption? Not 100%, or damaging an HDF5 file, not 100%, but once you, as part of the hardening that you would do for any HDF5 application that you use in production or any kind of production scenario, you will have that down to a science pretty quickly, so that the likelihood of that type of damage is extremely unlikely, and more often due to maybe hardware failure or something like that. So unfortunately, yeah, this has just been something that's been kicking around, and it rears its ugly head every once and so often. But yeah, we'll see. If we can find somebody who wants to take on this project or wants to sponsor this, then I think we'd be more than happy to do this. But unfortunately, for the time being, we have not had that opportunity. Okay, just check. Okay, we got 5 minutes, so we gotta speed up. And I'm gonna ask, are there any questions? Because otherwise we will cover this next time. No? Okay. Tips, tricks, and insights. So I recommend you read that article in HDF that's actually relatively low on technical content, but I wanted to answer anyway. The question is, well, how do these HDF user-defined functions, HDF5, UDF, actually work? And the key idea is really they are a very clever way of exploiting the HDF5 filter pipeline. And so there are basically two parts to an HDF5 UDF. Well, the first thing I should say, these HDF5 UDFs, they are just like data sets. So if you run H5 dump on them, or you in an application, you open such a data set, it's like a different layout. We have contiguous, we have compact, we have chunked, and you could almost argue and say, well, UDF is just another layout. There's also virtual, by the way, but yeah, so it's just another layout, and there's something that can be said in favor of that. And now this user-defined function itself is basically implemented in two pieces. Number one, there is something that actually implements the actual function that generates the data, either purely from an analytic formula, let's say, or that consumes input data from other data set or from a non-HDF5 file, and we'll see a CSV example in a moment. So there is a function like that. And secondly, there is, of course, actual, call it payload data, but it's really more metadata that's stored in the file in that data set as just a blob, which is basically JSON information that it's like a manifest that tells you something about the shape of the data set, the type. Then also, since we are talking about executing code here potentially, certain safety measures, trust profiles, Lucas calls them trust profiles, so that you want to execute only code from people that you trust, whose public keys, for example, you trust. And so just as a quick refresher here, this is schematically speaking the chunked IO pipeline. In this case, it's for write, which is sort of the opposite of what we are talking about here. An HDF UDF data set is actually a read-only data set. You can't really write to them. It makes no sense to write to them other than creating them. And so in your head, in this picture, what we describe is the chunked write, the H5D write flow, if you wish, but I'm talking about the H5D read flow. I couldn't just find a picture that was showing H5D read, so I apologize for that. But if you just revert the arrows, what would happen is, yeah, there is a chunk in somewhere, and then that file, that chunk, the surrounding data set, so to speak, will have some metadata that will tell the HDF5 library what, if any, filters need to be applied to this chunk before it can be sort of funneled up all the way to the application. And compression filters are a perfect example of sort of stages, if you wish, of that filter pipeline. But in the case of an HDF5 UDF, it is actually the function that can be written in C, C++, in Lua, and in Python at the moment. that generates the data that then populates that chunk that potentially goes into the chunk cache. And then in HDF, you have the ability to also apply getter scatter operations or do data type conversions and things like that. So if you just take that all the way back into then the data set itself, that's what the raw data chunk read looks like. So if you sort of keep that picture in mind, here's a figure that Lucas put together, a very pretty figure at that, I think, where you see basically, okay, the three ways at the moment how you can put these user-defined functions together in C++, where basically with Clang or with GCC, that code gets compiled into a shared library and then stored in the file with an additional trust profile again. So you don't, otherwise this would be like a computer virus or something like that that could just start executing code in the context of your application. And but other options are again Lua, sort of with just-in-time compilation, and Python. And they basically are controlled by what Lucas calls a UDF handler that ultimately then exposes this data set as an HDF5 data set that has a shape, that has a type and a value to an application. And again, you can run h5dump, all the tools, because it's just a chunk data set. That's what it appears as to applications. It blends in nicely with all the rest of it. And just to give you one quick final example here, I think one of the, and this is, by the way, an example, Lucas, the link is here, has a nice collection of use cases of predefined user-defined functions, contributed user-defined functions is, let's say you have a CSV file, so just comma-separated values, fields. And in this case, let's say you have a list of music albums, for example, and you would like to read this as a stream of records, as a compound type in HDF speak that has certain fields like the year when the album was published, some kind of row number, for example, before that, then the album title itself, the artist, the genre, and the subgenre. And here is how you put this together in Python, for example. There is a reserved name. Lucas always uses this name called dynamic_dataset in both Python and Lua, and also in C++. And then this is part, these lib.get something, they are part of the handler infrastructure. So lib.get get data would actually allocate a list of records of this type. So in this case, a compound type with 5, I believe, fields or 6 fields. And then you just do the usual thing. The way you would read a CSV file in Python is you just open the file with the right encoding, and then there is a readline method where you basically read in that entire file in one go, and you could read it also in blocks if that's what you want, in blocks of lines, that is. And then you basically iterate over this, and so you have a running count and then the line itself as a string. And on that string, since it's comma separated, you would run sort of a split and strip method. And here you have the list comprehension where you're extracting these parts. And then you basically take these parts and stuff them into this UDF data array that eventually gets returned to HDF5. And that's it. It's very simple, very straightforward. So I think, the official name for something like that is data virtualization. If you, a CSV file or similar text-based formats, making them appear as HDF5 is very straightforward with HDF5 UDF. And I think I have a few references. So here's the link to the GitHub repo. There's a nice read the docs documentation for HDF5 UDF And last but not least, this example was taken from a collection of few dozen, for example, coordinate transformations is another good example where you might want to use an HDF5 UDF rather than maintaining a separate library where you then have to read the data, apply the transformation to create other data. You can sort of do with HDF5 UDF, you can do that on the fly, and it's very elegant. And yeah, to me, this is a very interesting and novel and innovative contribution to HDF5. Anyway, that's all we have time for. We are 5 minutes over. My apologies. But yeah, thanks for coming. Thanks for asking questions, and come back next time.
Okay, thanks, Gerd.
Bye. Thank you.